Antibiotics early in life alter the microbiota, and this has long-term consequences. You tell us in your lecture. So the question is first, why should antibiotics change microbiota? What are these antibiotics doing?
Sure. So, antibiotics are designed to kill bacteria, right? To kill the bacteria that make us sick. But they're also, as we're increasingly understanding, they're killing the bacteria that make us healthy too.
So the good bacteria are dead. And what is the effect?
So what we're seeing is there are many effects. So our gut microbiota help us extract energy from food, and they regulate how much weight a baby gains, or an adult, but we think especially that this is important for babies. And so if we disturb the microbiota, we change the way the baby extracts energy from food and then gains weight, and we're seeing that this might have an impact on obesity later on, as well as other diseases.
So you mean when the wrong microbiota are there, the baby extracts more, they harvests more energy from the food?
Yes. So two babies eating the same food might extract different amounts of energy based on their gut microbiota. And we know that the antibiotics can change the microbiota, and so this might be one way that we find increased obesity in babies who've received antibiotics.
Okay, this is a very attractive hypothesis. Do you have proof?
So there's emerging proof, but I think we have a lot of research still to do, right? So there are studies that don't look at the microbiota, that just look at antibiotics and obesity, and they find an association. So there's more than a dozen of these studies now looking and showing that babies receiving antibiotics are more likely to be overweight when they're young children or even teenagers. So we see there's evidence for that. Then when we go in to look at the microbiota, there are fewer studies that have addressed this question, but we do see evidence that the antibiotics change the infant microbiome. We see that this happens, it's a long-term effect. So one exposure or a few exposures early in life can have a long-term effect on the microbiome.
What is the difference in prevalence? Infants who did not receive antibiotics during the first 6 months and infants who did?
So it depends on the population you study, because obesity rates are different in different parts of the world. But in general, we see things like up to a 50% increased risk of obesity. 50. Yeah, 50%.
And finally, animal models help to explain the mechanism. Can you elaborate a little bit on the
They do.
mechanism?
So the animal models are important because in babies, we're not manipulating the antibiotics or the microbiome, we're just observing. So in animals, we can deliver these antibiotics. We can deliver specific types of antibiotics to see if there's a difference between, for example, broad spectrum antibiotics and narrow spectrum. And we can also precisely look at the timing. So whether it's that early window, maybe even during pregnancy, we can look at that timing, and we can examine the microbiome. And we can do experiments where we transplant the microbiome. So from a mouse that's received antibiotics, we put that into a germ-free mice, and this gives us proof that the microbiome is actually causing an effect. So they're important.
And these experiments show what? More inflammation, or what are they showing?
So a number of things. The experiments in the mice are showing that if you give antibiotics to a young mouse just after they're born, you see increased inflammation, you see increased adiposity or fat mass. And this is especially true if you put the mice on a high-fat diet, and we think this mimics what's happening in developed countries where we're using more antibiotics than we used to before, and we're all eating sort of a worse diet than in the past. So we see inflammation, we see insulin resistance, which is an early sign of diabetes, we see increased fat mass. All of this in the animal models is supporting the hypothesis that antibiotics might be harmful.
So the message to the pediatrician is think twice before you prescribe antibiotics to young infants.
Think carefully. So we know that there are scenarios where we need antibiotics. Antibiotics are excellent drugs. They are life-saving drugs when they're really needed. But what some studies have shown is that up to 30% of antibiotic prescriptions are not necessary. So they're given, to example, for a viral infection, which isn't going to be affected by antibiotics. So we have to be careful. And I think that message is getting out there. We did a study in Canada in 1995, and we saw that 2 out of every 3 babies was receiving antibiotics before they turned 1 year old. That's a large proportion. We repeated that study in 2010, so 15 years later, and we saw that it was now 1 in 3 babies. So I think the physicians are getting the message.
So there's some progress.
Yeah, there's some progress, which is good to see.
Okay, thank you very much.
Good. Thank you.